Hello viewers, I am Kausalya. Today we are going to solve problem number 6 under the category Routh stability criteria. And the problem is the characteristic polynomial of a system is given by this equation. Determine the location of the roots on the S-plane and hence the stability of the system. Again, the characteristic equation is given. We have to tell whether the system is stable or not. And finally, we have to comment on the location of the roots also. Right. So, this is our given characteristic equation. The maximum power is 7. That is odd number. So, we have to select all the odd values. So, here s to the power 7, s to the power 5, s cube, s and s to the power, that's it, s to the power 1. And here you see s to the power 6, right? So the next is s to the power 4, s square and s to the power 0, right? The next step is forming a Routh array. So s to the power 7, right? Here we have to write the coefficients. So coefficient of s to the power 7 is 1, s to the power 5 is 9 and s cube is 4 and finally s is 36. Next, coefficient of s to the power 6 is 5 and s to the power 4 is 9, s square is 20 and finally 36, right? Since this row has bigger numbers, I am dividing this row by 5. So when you divide this by 5, what happens? 5 by 5 is 1 and 9 by 5 gives 1.8, 20 by 5 is 4 and 36 divided by 5 will give you 7.2. Right. Why we are doing this? Just to get simplified, just to make our calculation easy. You see, when you multiply 20 into 36 minus 36 into 4, the number will be quite bigger. Right. So when you divide, our calculations will be very easy. Right. So the next step is I am rewriting this Routh array again. Rewriting is nothing but in the place of S6, I can rewrite these rows. Right. So that is the thing I had done here. And the next step is, as usual, I am going to calculate s to the power 5. So what is the formula? 1 into 9 minus 1.8 into 1 divided by this 1. Okay, when you do this, this gives the value as 7.2. And to find the second element, you can hide this column. Right. How to multiply? 1 into 4 minus 4 into 1 divided by 1. So 4 minus 4 is 0. And finally, to get the third element, you can leave these two columns. So how to multiply? 1 into 36 minus 7.2 into 1 divided by 1. That gives the answer as 28.8. Right. Again, this row you see, when we can divide these two numbers by 7.2. So I am dividing it. So 7.2 by 7.2 gives 1 and here 0 and here 28.8 divided by 7.2 gives you 4 as answer, right? You see the things what I have told I had written here. That's it. Okay, how to get the values of s to the power 5 row. Here is the calculation, right? Again, here I had rewritten the Routh array. So finally we had formed values up to s to the power 5, right? 1, 0 and 4. And the next step is we have to find s to the power 4. How to find s to the power 4? You see, 1 into 1.8 minus 0 into 1 divided by 1, right? That gives the first value. And here to find the second value, you can hide this column. And how to find the values? You see, 1 into 4 minus 4 into 1 divided by 1. So that gives 0. And finally, to find the third element, 1 into 7.2 minus 0 into 1 divided by 1. So that gives the answer as 7.2. Right. So again, these two numbers are divisible by 1.8. So again, I am dividing and I am getting the answer as 1, 0 and 4. Right. The next step is we have to find s to the power 3. So to find s to the power 3, what is the procedure? You see, this is the simplified format of s to the power 4. So we can take this one. Right. So now you can leave this one and we can do as usual the calculation. So you see, 1 into 0 minus 0 into 1 again gives you 0. And to find the second number, 1 into 4 minus 4 into 1 divided by 1 again gives you 0. So, the s to the power 3 has row of zeros, right? The thing what I have said orally, here I had written, you see, how to find the first element of s to the power 4. This is your second element and this is your third element. Similarly, how to find the values of s to the power 3 row. Here we had find out, right? So, as we see, s to the power 3 has row of zeros, right? So when you have row of zeros, what is the procedure? You have to find the auxiliary equation. So the auxiliary equation is given by the row which is present above the row of zeros row. So the auxiliary equation is contributed by this row. So how to write the equation? You see 1 into s to the power 4, right? So the highest power is s to the power 4 here. So write s to the power 4 plus 0 into s square plus 4, right? So here I had written that equation. You see? So this is your auxiliary equation, s to the power 4 plus 4, right? So what is the next step? We have to differentiate. So once you differentiate, what happens? S to the power 4 becomes 4s cube. That is, this is the formula. When you differentiate this term, n into a to the power n minus 1 is the differentiated format of this term. So when you differentiate this, we are getting 4s cube, and you differentiate a constant, this becomes 0, right? So after finding out the values, now we are going to replace the row of zeros by this values present here. Here we are having only 4s cube, that is only one term. In the place of the s cube coefficient is 4, right? So here I had simply replaced 0 by 4 here because there are no more terms here. So after replacing it, again just calculate now what is our next step. We have to find the value of s square, right? You see, when you multiply 4 into 0 minus 0 into 1 divided by 4, what happens? This is again 0. So finally the s square row will be also having row of zeros. So this is totally a different problem, right? So look carefully. Even after finding auxiliary equation and substituting the values, again we are getting row of zeros. So what to do? You see, therefore we are dividing the characteristic equation by the auxiliary equation, right? Now we are going to do a division. For what? To get the quotient polynomial. Okay, with the quotient polynomial, it is easy for us to complete our Routh array. So this is quite different problem. That is, even after differentiating and finding an auxiliary equation, we are differentiating and substituting. Even after substituting, we are getting again row of zeros. So this is a typical problem. Now we are going to divide, right? So this is your given characteristic equation and this is our auxiliary polynomial, right? So the first thing is we are dividing, that is s to the power 7 divided by s to the power 4, right? You see, s to the power 7 by s to the power 4. What happens? This will give you s to the power 3, right? Because here 4 get cancelled, the remaining will be 3. So I will be having s cube, right? So here the first element is s cube, right? So after finding this, just you have to multiply these two terms. So s power 4 into s cube will give you s to the power 7 and 4 into s cube will give you 4s cube, right? Since we are having only two terms, you just write in their respective places. Under s to the power 7, we are writing s to the power 7. Under the place of s cube, we are writing the term s cube, right? So after writing this, we have to subtract. So due to subtraction, these two s7 terms cancel each other, and similarly this 4s cube and 4s cube cancels each other. Then write down the remaining terms here. So 5s power 6 plus 9s power 5 plus 9s power 4, and here plus 36s plus 36, right? So after writing this, again the same procedure, you just take the first term. That is, what is your first term? It is 5s power 6, right? So again we have to divide this 5s power 6 with the s to the power 4. So 5s power 6 divided by s to the power 4. What is the answer? You will be having this 5 remains as such. So when these two cancel, you will be having s square. Right. So here our second term is plus 5s square. Right. The next step you have to multiply. So 5s square into s to the power 4 will give you 5s to the power 6, and again 4 into 5s square will give you 20s square. Okay, we are writing under the s square term. So after writing as usual, we have to subtract. So when you subtract, these two terms cancel each other, and again these two terms cancel each other, and the remaining terms are 9s to the power 5 plus 9s to the power 4 plus 36s plus 36. Right. So the next step is again you have to divide this first term by s to the power 4. So when you divide, what happens? You see here I am dividing 9s to the power 5 divided by s to the power 4. So 9 remains as such, and this s to the power 4 and 5, there will be a single s here. So the answer will be plus 9s. So here I had written plus 9s. And the next step is again multiply. 9s into s to the power 4 gives you 9s to the power 5, and 9s into 4 gives you 36s. Right. So after writing, again we have to subtract. So when you subtract, these two terms cancel each other and these two terms cancel each other. And the remaining term is 9s power 4 here, and again here plus 36. Right. So again, what is your first term? It is 9s power 4. Now here again I am going to divide that one. So when you divide, you see 9s to the power 4 divided by s to the power 4. The answer will be 9 here. So here I had written 9. So 9 into s to the power 4, 9s to the power 4, and again 9 fours are 36. So just write down the values. So after writing the values, again you have to subtract. So when you subtract, we are getting the answer as 0, right? Because these two cancel each other, and again these two cancels each other, right? So the next step is we are going to write this characteristic equation as a product of these two terms. That is, this is your characteristic equation. Right. So this characteristic equation can be written as product of these two elements. Right. Hope you people understand. Or for example, you can take like this. Consider you are having 20 and this 20 should be divided by 5. So the answer is 4, right? So 20 can be written as 5 into 4. Right. Similarly, this characteristic equation can be written as product of these two numbers or these two expressions here. So that is the thing I have done here. This characteristic equation is written as product of two expressions. Right. Then the next step is we are constructing Routh array for the quotient polynomial. Here this is your quotient polynomial. Now we are going to construct Routh array for this polynomial. Here the highest power is 3. Right. So we start from 3. You see s to the power 3. Coefficient is 1 and here coefficient is 9. So we have to take like this, right? So 1 and 9 here. The next thing is we have to take these two elements, that is 5 and 9. Then the next thing is we have to find the values as usual, the same steps. You see 5 into 9 minus 9 into 1 divided by 5. So here when you solve, the answer will be 7.2. So just write here. The next step is again here the element will be 0 because there are no elements here. And again to find s to the power 0, 7.2 into 9 minus 0 into 5 divided by 7.2. So you see that again gives the answer as 9. So just write down the 9 here. Now you look at this auxiliary equation, when you look at this Routh array, tell whether there are any sign changes over here. There are no sign changes. Can we tell whether the system is stable or not? Yes. With this conclusion, we can say the system is stable, but that is not the actual case. Because we have to check the location of rows as we have row of zeros in our previous Routh array. Right. So we are going for that. So to find the location of the roots, we have to find the auxiliary equation. So here the next step is we are solving our auxiliary equation. You see, this is your auxiliary equation, and again we are replacing this s square by x. So I am having x square plus 4 equal to 0. So x square is equal to minus 4. Therefore x is nothing but plus or minus square root of minus 4. So here plus or minus, okay, square root of 4 is 2 and square root of minus 1 is j here. So the root which I am getting here is plus or minus 2j, right? We are having the value of x as plus or minus 2j. So the x is nothing but s square. So s square is plus or minus 2j, and again s is nothing but square root of, that is plus or minus square root of 2j. Again I am converting this into polar form, right? So here this is s equal to plus or minus 2 with an angle of 90 degree. So when you take square root of an angle, the square root of 2 remains the same. For taking square root of angle, we have to divide it by 2. So when you divide it by 2, we are having the answer as 45 degree, right? And the next thing is s is equal to plus or minus 2 with an angle of minus 90 degree. Again when you solve, you see you are having square root of 2 with an angle minus 45 degree. Now I am going to convert this into, now we are going to convert this into polar form. So here this is, converting to rectangular form. Now I am again converting it into polar form. So when you convert it, you see this is our root plus or minus 1 plus j1, and another one is plus or minus 1 minus j1. So totally how many roots are there? There are 4 roots, right? The first root is plus 1 plus j1, and again when you move this minus sign inside, that gives minus 1 minus j1, and here also plus 1 minus j1, and again minus 1 plus j1. Now we are going to locate the roots, and finally we are going to decide whether the system is stable or not. Okay, this is our S-plane, and this is your real axis, and this is your imaginary axis. Your first root is 1 plus j1, that is both are positive, so it lies somewhere here, right? And the second one is minus 1 minus j1, here both are negative, so this lies in third quadrant, it lies somewhere here. And the next root is 1 minus j1, that is 1, this is positive, and minus j1, so it lies in fourth quadrant. And finally minus 1 plus j1, so it lies in the second quadrant, right? So now tell whether the system is stable or not. The system is unstable. Why? Because 2 roots are lying on the right half of the S-plane, right? So totally how many roots for this problem? We are having 7 roots. So among 7 roots, 2 roots are lying on the right half of S-plane. Therefore the system is unstable, and the remaining 5 roots lie on the left half of S-plane, right? So that is the final conclusion here. You see, since 2 roots are lying on the right half of the S-plane, the system is quite unstable. And how many roots are lying on the left half of S-plane? 5 roots are lying on the left half of S-plane, right? The problem gets over here. Hope you people understand. Thank you.